Hey, sorry about that. My video only lets me record so long before it cuts me off. So let's go ahead and do our last example together from our second part of lesson 66. Again, our job is to identify all of our real roots, which are all of the answers that we have on this question. Now, this last example that we're going to work through, this one's going to be the most challenging that we're going to have to do together because we're going to have to do an extra step that we've never done so far in any one of our questions. The equation's already set equal to 0, so I don't need to worry about that again in this question. Like we did in our lesson yesterday, there are no common factors, and I can't break this down into two parentheses, so we're having to use this new idea of using the rational root theorem. The rational root theorem involves two different pieces, the constant as well as the leading coefficient. Now, the constant on this question is 3. So what can I multiply together to get a 3? 1 times 3. Just like in our previous example, don't forget you always want the plus and the minus sign as you're listing out your factors. Positive 1 times negative 3 or negative 1 times positive 3 could work to get the negative 3 that I had originally in the question. What are the factors of our leading coefficient? Well, the leading coefficient's 1. What can I multiply together to get a 1? 1 times 1. So once again, the factors of the leading coefficient would be plus and minus 1. In order to come up with your possible rational roots from our rational root theorem, we're taking our constants, dividing by the leading coefficient. Just like in our first example today, the leading coefficient is 1. So dividing by 1 doesn't do anything. So our possible rational roots happen to be the same thing as our constant. So plus and minus 1 and then plus and minus 3. Just looking at your homework questions real quickly here while I'm talking about that. It looks like on the questions that you'll be doing for me, the leading coefficient is going to be 1 on both of your questions, so your possible rational roots should be the same as the constant factors that you came up with in the question. Now, notice I have 4 different factors that I need to look at. Is it the positive 1 or negative 1? Is it the positive 3 or negative 3? Which one of those 4 numbers, if I put back into the question, is going to give me a 0, because that means it's going to divide the question out evenly. So let's go and start off with our positive 1. So 1 to the third is 1. 1 squared is 1. So 1 minus 1 is 0. The first two terms knock each other off. 13 times 1 is 13, so I have negative 13. Negative 13 minus 3, though, is negative 16. Well, I don't want negative 16, so that's not the one that I want. So I got to move on to the next factor, which would be negative 1. If I put negative 1 into my question, negative 1 to the third power is negative 1. Negative 1 squared would be positive 1. So negative 1 minus 1 is negative 2. As I continue, negative 13 times negative 1 would be positive 13. So I had negative 2 plus 13 now, but that's going to be 11. And 11 minus 3 is 8. So again, that's not the number that I want in the question. So I'm going to do the same thing with the positive 3. If positive 3 doesn't work, then I would go to use the negative 3 in our question. Now, unfortunately, the positive 3 is not the one that works either. It's actually the negative 3 that's finally going to give us a 0 if I put that back into the question. So what does that mean? Because the negative 3 worked in the question, one of my factors, one of the two parentheses I'm going to have is going to be x plus 3. It's the opposite of what I had in the answer, just like we saw in yesterday's lesson. Now that I came up with one of the possible roots, one of my possible answers, I want to start into the synthetic division to find the other part of this original polynomial. So setting up my synthetic division. Inside of the box, I put negative 3. I put the number that I got 0 out of from the previous slide. My 1, negative 1, negative 13, and negative 3 were the 3 numbers from the original, the 4 numbers from the original question. Our synthetic division process tells us to drop down the first term and then start multiplying. So 1 times negative 3 is negative 3. I add that together with the negative 1 and I get negative 4. Negative 4 times negative 3 is positive 12. Negative 13 plus 12 is negative 1. Negative 3 times negative 1 is positive 3, and there's the 0. Again, that's what you want to see at the end of your question to know that you've done the question properly. Once you've divided, you can write down 2 parentheses. The first parenthesis involves the number that we found from the first couple steps of this question. It is x plus 3, because I have to put the opposite inside the problem. Once again, the original question started off with an x to the third, so after I divide, my exponent's 1 lower is going to be an x squared. So I have 1x squared, or just x squared, then minus 4x minus 1. The remainder is 0, so I don't have that all inside of our parenthesis, and our equation still equals 0. If I were to multiply those two parentheses out, that would have been the original polynomial that was given to us in our problem. Now, just like we saw in the previous question, I need to continue to solve for the other roots in our question. So far, I only have 1. I know that -3 works, but I'm supposed to have a total of 3 answers because of the question saying x to the third. Well, the other 2 answers are going to come from the second parenthesis, where it says x squared minus 4x minus 1. On the first question that we did today, we saw that we could factor. There was something that we could multiply to get that 6, and then add it together to get our -1. However, on this question, there's nothing that I can multiply to get a 1 that also adds together to give me a 4. So here's the one extra special thing that we're going to have to do on this question to find the other 2 roots in our problem. Right before a break, we did lesson 65 where we learned about the quadratic formula. Remember that weird song that I had you guys sing together with me in class? So we're going to have to use that quadratic formula to help us come up with our other 2 answers for x. In the quadratic formula, we had to identify our a, b, and c. The a was the coefficient of the first term, and that would be the the 1. The b was the coefficient of our second term, the one that had the x, and that coefficient's -4. And then our c is the constant, and that's our -1. So for the time being, I'm going to set aside the x plus 3, and I'm just focused on the x squared minus 4x minus 1. So let's go ahead and try to do the quadratic formula using that trinomial. So I went ahead and filled it in fourths. So the b was -4. Well, in our quadratic formula, it says -b. So -4 is +4, and I have that at the front of our question. Then plus or minus, inside the square root was b squared minus 4ac. So I have -4 squared minus 4 times the a, which was 1, times our c, -1, and then it was all over 2a. So the a was 1, so 2 times 1. Let's work through the arithmetic. Again, most of it's inside of that square root. So -4 squared, -4 times -4 is +16. And I like to include the minus with that 4 as I do the second part of the multiplication. So -4 times 1 is -4. -4 times -1 is +4. So inside my square root, I now have 16 plus 4. Then in the denominator, 2 times 1 gave me 2. Continuing to simplify inside our square root, add those numbers. So now I have 4 plus or minus square root 20 all over 2. Now, I don't know the square root of 20, so what do we do with square roots that we don't know? We have to factor tree them. So 20, I could do 2 times 10, and then 10 2 times 5. I do see I have a group of 2 that can move out to the front. So now I have 4 plus or minus 2 root 5 still all over 2. Now, anytime we have a fraction, we know that we're always supposed to try to reduce it before we can mark down our final answer. So what can I do in order to reduce this question? All 3 of the numbers that are not inside of our square root, which are the 4, 2, and 2, all divide by 2. So 4 divided by 2, that's going to replace with the number 2. 2 divided by 2, well, that would cross off. And 2 divided by 2, again, that would cross off. So we've knocked off the denominator in our question. And now I have 2 plus or minus root 5. Notice there's actually 2 answers sitting there. There's 2 plus root 5, and there's 2 minus root 5. Those are the other 2 answers that I need in the question from the second parenthesis that had the x squared. Okay, so just wrapping up this question. Remember, there was my first parenthesis, the x plus 3. That was the other parenthesis that we were working with, the x squared minus 4x minus 1. Now, inside, I broke that parenthesis down into 2 separate parentheses. So x squared is x times x. So those are the x's that I have inside these first 2 blanks. From the quadratic formula, we got the answer 2 at the beginning. So notice inside both of these parentheses, I put minus 2. I put the opposite inside the parenthesis. Well, remember, we had plus or minus. So if I start with plus root 5, then I put the opposite for minus root 5. Then the answer said 2 minus root 5. So again, I put the opposite, -2 plus root 5, and our question is still equal to 0. My goal at the end, again, is to give the answers for x. The answer for x is the opposite of what I see in the parentheses. The first parenthesis, that's the easiest one. That's one we've been focused on so far. All I see is plus 3, so my final answer is going to be negative 3. The second parenthesis has two different numbers. I need to do the opposite of both of them. So I have positive 2 plus root 5, and the same thing for my third parenthesis. There's two different numbers, so I have to give the opposites of both of them, 2 minus root 5. That idea at the end there, the 2 plus root 5 and the 2 minus root 5, that goes back to that irrational root theorem that said the answers were going to be in conjugates. Because I had 2 plus root 5, that means I have to have 2 minus root 5. It's based on the quadratic formula that you have that plus minus sign near the beginning of the question. My answer makes sense because we do have 3 answers, and the original question did have an x to the third on your problem. Looking at your homework questions that I want you to do from your lesson practice for E and F, both of those questions are going to require you to use the quadratic formula to come up with your second set of answers once you find the first rational root that gives you the answer of 0. If you're struggling, you've got questions, do feel free to contact me, and I'll be glad to walk you through some of these different questions.